is Mr. Heeren, and what I'm trying to do here is walk through Unit 6. So I want to walk through the review with you so you know exactly what's going to come, exactly what can happen. So so you can see, this is your review. So I want to walk through and look at kind of what this unit entails, and kind of what are the big ideas. And hopefully this won't take me longer than about 15 minutes. So right away, looking at number 1, this has got to be exponential growth. Growth tells me that this is going to be a plus. Now I got to make sure that this is in decimal form. If it's not in decimal form, I need to make it in decimal form. So 6 is my original. I'm going to go 1 plus 0.35 or t, or whatever you want to put up there. So remember, this is what's constantly changing. So if I wanted to make a little table here, I could go r, and then I could go, this is what the function's going to go. So I could go 1, 2, 3, 4, 5, and then I would put that in there for r, calculate it out, and get a basic idea of what that graph is going to look like. So when I do that, and I'll kind of use a calculator to help me here. When I do that, I do this. If I put in 1, or if I put in 0, if I put in 0, I'm just going to end up here at 6. All right, if I put in 1, I'm going to end up at 6 times 1.35. So that's going to be at 8.1. And I put in at 2, I'm going to be at 10.95. And you can start to kind of get an idea of what it's going to look like. So now, when I do that for number 2, there's one big difference. The big difference is that you're talking about decay. All right, so when you talk about decay, you're talking about this. So instead, I'm going to subtract here. So it's going to be 16, 1 minus 0.185 raised to, this time we'll call it t. It's not in decimal form, so I make it in decimal form. So I'm going to subtract that. So this becomes 1 minus 0.185. That's going to be 0.815 t. Now, here's where it's screwed up, because you have got to do the exponent first. So if I go, t is 0, 1, 2, 3, 4, 5, whatever, then I've got to do the exponent first. Otherwise, I'm going to be in trouble. So at 0, I'm at 16, which is right here. At 1, I'm at 13.4, which is right about there. 13.4. At 2, I'm at about 10.6. 3, I'm at about 8.6. 4, about 7.05. 5, I'm at 5.75. So you can kind of start to get an idea what. So that should be kind of what your graph looks like. So now, if I jump down here, number 2, or number 3 rather, here's what I'm looking at. Value of Apple's iPad as equipment decreases the more it is used according to the exponential function of here. So in this equation, X is the number of years that have passed. What is the value of the equipment 6 years after it was purchased? So very simple idea. But here's where kids get screwed up. Some kids will try and multiply this part and this part first. Don't do that. You've got to multiply this part first. So you got to go 0.77 raised to the 6th first, then take that number times 200. So when you do that, you get a whopping $41.68. That's going to be all I do, but I got to do it correctly. So that's what I'm going to do. 0.77 raised to the 6 times 200. Number 4. I multiply this first. So if I let x equal, 0, 1, 2, 3, 4, just to kind of get an idea of what this looks like. So if I put in 0, that's 0.4 times 0, raise 2 to that power, and then multiply that times 100. So 0.4 times 0 is going to be 0. 2 raised to the 0 is going to be 1 times 100. This is going to be 100. So if I plug this in the calculator, I look at the table. At 1, I'm going to be at 131.95. 2, I'm going to be at 174.11. 3, I'm going to be at 229.74. 4, I'm going to be at 303.14. So you start to kind of get an idea. So like if I started off, wherever your graph is, if I started off down a little bit, come on. So if I graph this thing a little bit, so if I graph this thing, if I said that this is 100 and where I started, so by the time I get to 1, I'm at 130. So it's going to kind of take off like that. So that's what that's got to look like. All right, so here, you're starting to look at population. You got to read the problem, otherwise you're going to do it wrong. Population has been growing at a rate of 0.2% per year. Now, don't get caught up in the 0.2%, all right? You still got to move it over 2 places. This is still percent. It's not in decimal form, so I got to move it over. So if I start off with 7,560,000, it's going to be a growth of 0.002 raised to the power of t. So write equation, predict population of origin in 2015. Well, don't put, as some kids will, 2015 up here, because that's not what you're marking. This would be marking the population since the beginning of time. That's not what you want. From 2000 to 2015 is 15 years. That's what you want. So once again, you're going to raise 1 first, multiply 168,000, and you get 7798246. And we'll round it there because you can't have like partial people. So that's about 7 million. So now let's jump into the Walmart one. So Walmart is used to making money. I don't do it anymore because everybody's got their own printer. It's decreasing at a rate of 1% each year. So now 13% as a decimal is 0.13. So I'm going to start off with 70 grand. 1 minus 0.13 to the t years. So now this one's very direct. This one just says after 15 years, how much money are they making? So 1 minus 0.13 raised to the 15. So I take 1 minus 0.13 because parentheses go first, raise it to 15 because exponents go next, then multiply it times that. So after 15 years, they're only making about $8,667.36 off that. All right, now, the investment problems. The investment problems, kids have a problem with these basically because they don't read the problem all the way through. So $1,000 is invested, 6% compounded semi-annually for 13 years. So $1,000, 1 plus, and here's where I got to be careful, 0.06 divided by 2, because it's semi-annually, and then up here, since it's 13 for 13 years, times 2, because I'm doing it twice a year. So now here's where I've got to be very careful with order of operations. So I've got to do this first, 0.06 divided by 2 plus 1, so this becomes 1.03. Now I raise that to 26 power, and you get a big long decimal times 1,000. So you get 2156.59. So that is roughly what that investment will be after 13 years. But I've got to be very picky about that. Very, very picky about how you do order of operations because it's really easy to screw up. All right, next page. Polar bears. Polar bears are dropping off. That's kind of sad. There were an estimated 200,253 polar bears living in the Arctic. They're dropping at a rate of 0.3%. Remember, as a decimal, it's going to be 0.03. So write an equation to represent this situation. We start off with their 2,000 200,000. They're at a rate of 0.003 for each year. So this is at 245. They started in 2004. This is where I said you got to read the instructions. So how many years is that? Well, 2045 minus 2004 is 41 years. So you're going to put this in to this form like that. First times 100,250. That's going to be 143.7182. So about 177,000 polar bears left. All right, so city of Farmington house values go up at an annual rate of 3% per year. That's pretty nice. Susie's family bought a house for $30,000. 1 plus 0.03% per time in years. Estimate their whole cost of their home in 2023 if they started in 1995. So 39,000, 1.03 because you're adding. 1995 to 2023 is going to be 28 years. Times 39,000. So that's going to be $89,229.18. So after 28 years, their house has now gone from $40,000 to $90,000, which is a pretty good deal. All right, so last problem, I believe. Determine the amount of investment if $400 is invested, an interest rate of 3.25% compounded weekly for 5 years. So start off $400. You're going to compound it, so it's going to be 0.0325. Be careful with how many times you move the decimal point. Over 52 because there's 52 weeks in a year. Raised to the 5 times 52. So 0.0325 divided by 52 plus 1. 0.0325 divided by 52 plus 1. Raised to the 52 times 5 times 400. After all that, you're going to get $470.56. All right, so be very, very careful, especially if you did not get that. Be very careful with your order of operations. If you do this wrong, then you're going to get a wrong answer. Also, try and keep decimals as long as possible, and try and keep them in your calculator as much as possible. All right, if you have questions, come talk to me. Otherwise, be ready for the Unit 6 quiz as soon as possible.